Hi, Brian Maestri. I'm an economist with Mississippi Valley Division, and today I will be using the Coastal Texas CSRM evaluation as a case study to discuss foundation height sampling and the development of storage tank depth damage relationships. If you look at the slide off to the left, you can see there's two structures. One is right on the ground, a slab foundation, and a little bit in the distance off to the right, you can see other structures that are built up. And this was a very large inventory, and we had very generic information about foundation heights, and so there was very large uncertainty, and we felt we needed to collect more information for our structure inventory in order to use it in the evaluation to assess flood risk. So we did sampling, and that will be what I will be presenting on. Another unique aspect of the study area, as you look right in the middle, is the storage tanks. This area is very industrial, as you can see off to the right. There's Texas City, which includes a tremendous amount of industry related to oil and gas and chemicals. And the storage tanks were spread throughout the area. And we really didn't have a way to address it until we got some unique information from professors at Rice University to help us develop those depth damage relationships. And I'll be discussing that later. But first, I'd like to address the foundation height sampling. We'll give a brief introduction on the study area. Then we're going to look in this part of the case study. We're going to look at a 10-step process that was used for foundation height sampling, and then discuss the results and conclusions. First, as an introduction, the Coastal Texas study encompassed the entire coast of Texas, as you can see from way down in Brownsville, Region 4, and it was broken into 4 regions. In 3 of those regions, 2, 3, and 4 were ecosystem restoration solutions to flood risk, whereas the area I was the lead economist and I was working on was Region 1, which was a CSRM, in which there is proposed a large gate at the Galveston Bay that leads into the Houston Ship Channel, along with supporting levees and flood walls and dune systems to reduce flood risk. There was a recon study. It had congressional support. And one of the impetus for this study was the flood history. Hurricane Ike affected this area in 2008. It absolutely devastated Galveston Island and went up slightly east of the Houston area with storm surge, and that was really the storm of record for this evaluation. So in order to conduct the economic analysis, this is a very large study area. We collected an inventory of over 214,000 residential and non-residential structures, and in the slide you can see the purple dots show the location of those structures between Galveston Bay and all the way up toward the city of Houston. As I discussed, there were such a large area, mainly residential and non-residential structures. There were different foundation types and heights. And the information we had was very generic. It was based on a 5-state area of here's this type of foundation and this is the typical height of it. And we felt we had to get more specific information. So you can see the types of foundations, as you can see at the top. Those structures are just like crawl space, not very high off the ground, pier pile foundation. And then at the bottom you have a closed pile foundation and open pier foundation. So there's all these various types of foundations that you see. Moving on to the other slides, there were hardly any basements, just like as where I'm presenting from in New Orleans with our water table and our ground being marshy. We don't have basements like they do up north. But you can see there's a lot of, looking at the bottom, you can see fill raising the elevation of some structures, and some structures were just slab on grade and hardly, very, very few inches off the ground. So there's a lot of variation in foundation height. So now I'd like to go through that 10-step process of how we address foundation height sampling, and something that you could consider if you decide to employ sampling for any of your important economic parameters. So the first step was to divide the area into distinct areas for sampling. We call them areas of interest. We tried to, based on our surveys and just driving around and talking with folks who were very familiar with the area, divide the study area up so that we could try to reduce the variation in foundation heights. So we tried to get areas that were mainly pier or pile foundation, or areas that were mainly slab. And of course, you're going to have a mix up in there, but you did the best you could, and it was divided into like 24 areas of interest. So that's very important to kind of get your samples so that you're trying to reduce the variation. And then there's some statistical formulas that was step 2 that was applied. And here you see your sample size N is equal to your Z-value. Your Z-value is what you get from a statistics book, and it's based on your level of confidence. And the Z-value, most core studies use a 95% level of confidence, so the Z-value was equal to 1.96. And then that was multiplied by the sample standard deviation. Now you can do a small sample or a little pilot study to get an idea of what's the variation to get at your standard deviation. If you don't have any idea what it is, you can do a guesstimate. It's the maximum, for example, foundation height. What's the maximum foundation height minus the lowest foundation height? And then take that difference and divide by 6. That's called the 6 sigma rule for a normal distribution that would kind of cover the entire universe. So that's a way of a guesstimate of getting at your standard deviation if you don't know it, and it's what we used here. And then E is the allowable error. And for pile or pier foundations, we were willing to say we were a foot off if it's way up in the air. And if it's a slab foundation, we were willing to be 0.3 of a foot off. So that all works into your sampling formula. So just to apply some numbers that we did, again, using a 95% level of confidence to 1.96, and then we had to estimate that standard deviation. We said, well, we think the maximum pier or pile foundation height is going to be 13 feet. And if it's a pier or pile foundation, it's going to be probably 2 feet off the ground. And that divided by 6 gives you 1.83. You plug that into the formula and you got 13 structures. Well, that's where we started, but we saw some of these areas had structures almost 20 feet off the ground. So actually, if you had 20 minus 2, that's 18 divided by 6, which is 3. And you plug 3 in times the Z over the error squared, that gave you like 31, 32 structures. So again, it depends on, what you think is appropriate. And these we're looking at the pier foundation type structures. As I said, not all of the areas only contain pier, only contain slab, and so then there's these proportioning structures. And you can see it's got to be equal to 100%, so 95 and 5%, if you think it's 95% pier and 5% slab. And you can plug that into your formulas, and you, again, apply your 1.96 for a 95% level of confidence. And then the amount of error, we were willing to be 5% off on that. And you can see here's an example of where if it is 95%, say, slab and 5% pier, or it's the other way around, you would do 73 structures. But if it was 50-50 and you plug those numbers in, you have to do 384. So again, the more variation, the larger your sample size. And of course, your allowable error that you're willing to, and we said 5%. Willing to incorporate. So we applied that to our study area, to those what we call our areas of interest, AOI, our areas of interest. And you can see that of the 200, as it ended up being about 210,000 structures, our sample size was a little over 4,200 structures after we applied the formulas. So step 3, now that we know how many structures in those areas of interest, now we got to go identify those structures. And you could drive and go to the structures. Instead, what we did is we used actually collected information using Google Street view of things. And so here's 3 example structures. You see the structure ID number, and then we got the height above ground that the first floor is. And you can see that first structures is estimated to be 8 feet. We know we could be off a foot. The teams that we put together was some students with GIS experience, and they actually calculated how much a step is in bricks and how many inches they are. So we had people experience with that because, again, you can do the best you can looking at a picture, but you should be able to be within a range, a reasonable range. And then we said, what type of foundation type? And we just classified everything as it's either a slab or it's a Pier foundation if it's built off the ground. And then the number of stories, since we didn't have great information on that, and we have different depth damage curves for 1 story and 2 stories, so we wanted to collect that information also. And then we categorized it. Was it a residential or non-residential structure? And then you could write some notes. And we said, oh, that first structure is an enclosed pile. That second structure you see in the middle is an open pile foundation. And then you can see that third structure there was a slab just barely off the ground, was a restaurant. But that's the basic information we collected. So steps 3 was to assign your unique ID number and then determine the information that you want to collect. Which then left us to, now we're getting to our results. So we collected the samples, as I said, using Google Earth Street View and GIS tools. And I'm just going to show you 2 of the areas of interest. If you notice across the top, we have the different types of residential structures for our depth damage curves: 1-story pier, 1-story slab foundation, 2-story pier, 2-story slab foundation. And we sampled 73 structures in this first area of interest. And 66 of them were 1-story pier foundation, so it was very near the coast. And they were about 12 feet off the ground. So 90% of our sample was a 1-story pier. And then 1-story slab, there was only 1 structure, was only like a little over 1%. And 2-story pier foundation, there was 6 structures, which is about 8%. That should equal up to 100, and we got the average height. Now we went to area 2. If you notice the pier, if you add up the pier, it's over 70%. So it's a little over 70% pier. And when you take the 1-story slab and the 2-story slab, it looks like, about, obviously got to equal to 100, near 30% being slab foundation. And then we had the average height that we got for those. The number of structures, we did 340 in that area. And you can see the information along row 2. Now we did this for all 24 of the areas of interest, and then we got up a weighted average for the study areas. You can see that 5.23 feet was the average height of a 1-story pier off the ground for the entire study area, and then for a slab it was about 0.7 of a foot. So you can see the information. So we collected on about 4,000 structures ultimately with our teams. So looking at the steps, we collected the samples, then we assigned the foundation heights to the sample structures, and then we developed the results for each area of interest. So moving on to step 8, we then had our, as it ended up being 22 areas of interest, 2 of them dropped out, and you can see we have an average foundation, 1-story pier average height, 1-story pier standard deviation, and the slab average height, and the standard deviation for the slab. And you can see the weighted average for the entire area. So now we assign these foundation heights to the structure inventory. So these areas, for example, area 2, what did we say? We did 384 structures, but they were really close to 15,000 structures. So if we knew what proportion were 1-story and 2-story, and then what proportion was slab and pier, and then we had that average height, and that's what we assigned to the rest of the inventory. So are we going to be exactly right on each individual structure? No, we're not. But this is a large coastal study, and really, if long as we got it right for the area, this would be deemed good enough. And so so we actually use that average height for Pier and Slab that we collected, and we applied it to the reaches then that fit into those areas of interest. And we had the uncertainty with the standard deviation. So then from our step 8, after we discussed, we assigned the heights to the rest of the structure inventory. Step 9 was we used the results to develop the uncertainty ranges surrounding the foundation height. And you can see that we had the average height and the standard deviations that went along with that. And we had the lowest height of a structure and the highest above the ground for the different types of structures. It gives us a range. And finally, you can see for non-residential, that was for residential, and then for non-residential, there wasn't quite as much variation there. But you can see the average foundation height is only 3 feet above the ground for a 1-story and 6 feet for a 2-story. But now we had much better information to use for our foundation heights. And when you're looking at a flood risk type study, what's the most important thing? That foundation height relative to the height of the water, right? Does the water get into the house? And so the generic information we had about the foundation heights, we thought that wasn't good enough for this evaluation. Now, you got to walk that line of that we could have sampled more, but you got to look at your study funds. What do you have available? How important is this to the analysis, and how much funding do you have? Because remember, we got to do a whole damage analysis also. So we did put some money into this and some funding and resources in order to reduce the uncertainty associated with this parameter. So my concluding remarks is just that, to determine the significance of the variable to be sampled, to the results, and the importance to the decision. We felt that, foundation height could affect our decision of whether something was feasible or not feasible. So we decided, yes, we need to put, but again, that doesn't mean we came up with the greatest inventory for that area on every structure, but we couldn't have finished the rest of the analysis. So, there's those trade-offs. So use your study funds wisely in choosing a sample size. And it's always important to incorporate risk and uncertainty in all aspects of the evaluation, because into that HEC-FDA model, we were able to put a standard deviation associated with the structures by the foundation type in those areas. So that's really all I had for the foundation height sampling aspect of the Coastal Texas case study. I hope this was helpful for you. You can apply sampling to structure value. Instead of just using foundation, you'd use structure value if that's what you're using, and other aspects. Brian Maestri here. Nice to have you there.